chase an answer, just, don't give up. I think you have to have love of symmetry, patterns, colour, an enjoyment really of what you see and what you discover. My name's Judith Howard. I'm a chemical crystallographer working at the University of Durham. Crystallographers come from many different scientific disciplines, but what we have in common is the technique that we use and the methodology, so that the small samples that we use, and these can be small crystals of a chemical nature or biological nature, and we're using diffraction methods to unravel the internal structure, in other words, how the atoms are arranged that make up that material. What we derive from the experiment are intensities. So if you imagine a wave, the height of that wave, as I'm drawing it, would be what we call our intensity. We can then work out, by the same mathematics that they used 100 years ago, a Fourier series. And it's the Fourier series which enables us to reconstruct the electron density that's inside that crystal. And the peaks in the electron density are the atoms, and that is because we're diffracting the X-rays from the extranuclear electrons. Instead of having to calculate each Fourier layer slowly by hand, plotting it out carefully with the contours, the structures now will evolve before your eyes, if you like, on a computer screen. Once you have the basic atomic molecular structure, that begins to open up any number of avenues that you can explore. And of course, when we started, at least when I started, it took around about a year to solve relatively simple molecular structure. Now we can do several before coffee in the morning, and that's just in the lab. I find the whole thing, the crystals themselves are beautiful and pretty. The diffraction pattern is pretty, because if you actually get spots, then you've got a crystal, you've got order, you've got periodic order, which means that you have actually got something you can work with. So that's exciting, and it's also, some of the patterns are really lovely. I started studying the subject when I was an undergraduate student in the 60s, and then I went to Oxford to study for my DPhil with Dorothy Hodgkin, the Nobel laureate, and huge influence in my life. Dorothy, of course, started amazingly in 1934-35 to look at protein crystals. They had no way of solving the structures, but they knew that if they could get diffraction from these crystals, that then someday they would eventually solve the protein structures. And Dorothy had an amazing knack, intuition of, first of all, choosing the right problem and then being able to solve it. So she worked on vitamin B12, she worked on penicillin. And the insulin crystals, which she had in fact taken photographs of in the end of 1934, that structure was not solved, published until 1969, which is an amazing 35 years. Today people will be expecting to solve that in 35 days or less. We can get to know more and more about the structures of the proteins, but that's only the beginning. It doesn't tell you how they work necessarily. And biology is just amazingly complex. The way we work, and you work differently from the way I work, and the next person, and so on. What's going on at the molecular level? We know a lot, but there's plenty more to find out.